In this video, we're going to explain recursion. Here's an example of a simple recursion problem, which represents the recursive process to get the factorial of a number.
What better way to explain recursion than with Russian dolls? So the Russian dolls represent the input of the function. In our case, the input starts with the largest Russian doll, which is going to be 3. So we're going to start off with calling this function with an input of 3. So our in is going to equal 3. So it is going to move down into the else statement. So we return 3 times the factorial call for n minus 1, which is 2. So that is the first step.
And then our function breaks down the original problem into a smaller problem, which is the next recursive step. And this is the factorial of 2. So we know that 2 is more than 1, so it goes to the else statement, which is 2 multiplied by the factorial of n minus 1, which is 1. So it's going to return 2 multiplied by the factorial of 1. And that's how our function breaks down the original problem into a smaller problem and keeps going.
So now our problem is going to be broken down one more time into an n of 1. So our n is going to be equal to 1. So if you look up here, it goes into the if statement of n is less than or equal to 1, which is our base case. So as you can see, we return 1. And that ends the recursive callings for our factorial function.
Right. So the recursive function builds the result as we go from the base case, which is the solution to the smallest problem, which is 1, to the original problem. So we substitute the result of the base case, which is 1, to the previous problem, which is going to be 2 multiplied by the factorial of 1. So we know that the factorial of 1 is 1, so we substitute it in the second case, and then we get the result, which is going to be 2 multiplied by 1, which is 2. And then we take the whole result from the second step and we substitute it in the first step, which is the result to our original problem, which is going to be 3 multiplied by the factorial of 2. And from the previous step, we know that the factorial of 2 equals 2. So we're going to substitute it here and we get 3 multiplied by 2, which is going to be 6. And that's going to be our final product for the whole problem.
So as you can see, there seems to be a pattern. Well, there's a reason for that. So there are 3 laws of recursion. So those 3 laws are as follows. The function must have a base case, which you can see here and is noted in the comments. So the base case is the smallest possible problem that can't be broken down as stated previously. The second law is that the function must work towards that base case until it is reached, which you can see here from the recursive call that subtracts 1 from n. The third law is that the function must call itself recursively, which you can see here inside of the factorial function. It is called recursively in the else statement. So we hope that this explains recursion